I'm Enli, and this is my two-dimensional motion video analysis project. In this video, I'm going to explain how to use the two-dimensional kinematic equation to describe the projectile motion of myself doing an aerobatic trick. The first equation seen can be used to calculate the vertical component of motion for an object moving in two dimensions. The vertical component of an object's velocity is changing. The object's acceleration is negative 9.8 meters per second squared. The second equation is used to calculate the horizontal component of motion for an object moving in two dimensions. The horizontal component of the object's velocity is constant, and the object's acceleration is zero because there are no other horizontal forces affecting it. Change of x, initial velocity, and acceleration are the variables needed to determine the amount of time the object is in the air. Initial velocity, time, and acceleration are the variables that determine the height and distance the object travels. The angle seen in the first equation affects the velocity of the x and y components. This is an aerobatic trick called an aerial, which moves in the shape of a parabola, and the correct way to do it is in a straight line. The carpet is perpendicular to the camera, meaning the trick is perpendicular to the camera, because I lifted off and landed on the designs on a straight line on the carpet. I set a tape measure parallel to the carpet and marked the two ends with boxes to make it easy to see. The camera is flat against the wall, sitting on a level ledge of the fireplace. Mainly, I had to trust the straight lines in the room. This complete motion is 0.6 seconds long. I analyzed the video through Logger Pro. Here's the video being played once more. I click this button here and a graph shows up as well as a sidebar. I'm now changing the axes. Okay, so I'm going to focus on the ankle because it is the biggest range of motion, and the foot and the heel switch directions in the middle of the movie. I pause it right before the ankle takes off from the ground. And the action was pretty fast, so I have to estimate where the ankle is, which will cause some error. Okay, so this is the final graph of points. Now I'm going to set the scale. Right there. As the two boxes that I mentioned before. And that is 1 meter. Okay, so I'm gonna fit a quadratic to the curve. And here it is. I want to find the values of the velocity and acceleration. The top equation is how Logger Pro sets up a quadratic. The equation below it is a equation mentioned in the beginning, reorganized so that the coefficients can be set equal. A equals negative 0.8828. We set that equal to 1/2 times acceleration. 2 times 0.8828 is 1.77 meters per second squared, otherwise known as the acceleration. B is 5.563, which is also the initial velocity with units meters per second. C is equivalent to the change in x. The numerical value is negative 5.827. Of course, there is some sort of error in C because the change in x cannot be negative. Using the numbers from Logger Pro, I plugged them into the quadratic formula to find the change in time. Calculations say 0.92 seconds, but when recording it, it says 0.6 seconds. These results do make sense because due to error, it should be the slope. These results do make sense because due to error, it should slow down the action. The actual time would be the lowest. In order to do an aerial, a person can have fast legs or a lot of power at takeoff. In my case, I have fast legs, allowing my feet to land before my hands. Maybe measuring my ankle was not the right place because the shape of the graph was more of a horseshoe shape than a parabola. Through analyzing this video, I am able to learn how physics can relate to real life.